Hey guys, today we are going to talk about casting, more specifically a casting method known as sand casting. Casting is an old manufacturing principle that allows for large form freedom. Casting is used for anything from engine blocks to pots and pans. Sand casting is a casting method where you pour liquid metal into a sand mold. In order to start sand casting, you will need a metal foundry and a sand mold. In order to make a foundry, you need a stainless steel bucket, ceramic fiber, an air supply hole, a steel pipe, a hairdryer, a crucible, and charcoal. First, you need to line the bucket with the ceramic fiber. Then you need to drill a hole on the side of the bucket for the air supply hole. Next, you can duct tape the hairdryer to one side of the steel pipe. In order to make the mold, you need some wood to make the cope and drag, casting sand, and a 3D printed part to make the negative space for the mold. First, we 3D printed the part we wanted to cast for the negative space, and 3D printed some cylinder pieces to help us make the sprue. Then we constructed the cope and drag using the wood, and finally we packed our sand into the wooden structure. We encountered one problem during this process. When we tried to pull our 3D printed pieces out of the sand, it would break the mold. After a few attempts, we figured out that the sand was getting stuck in between the layers of our 3D printed part. In order to combat this, we taped the sides of our 3D printed part and repacked the sand into our mold. After we fixed this problem, we made a path from our part to the sprue and poked ventilation holes into the cope. Now we were done with our mold and ready to melt our aluminum. In order to melt the aluminum, we set up our foundry. We put a bed of charcoal on the bottom of the foundry, then we put the crucible into the foundry and placed charcoal around the crucible. We then placed the steel pipe with the hairdryer into the air supply hole. Then we started the charcoal and let the foundry heat up for a few minutes before using it. After the foundry was done preheating, we started placing cans into the crucible through the hole in the lid and occasionally adding charcoal to the foundry. When the crucible was about 70% full, we removed the slag. Then we continued adding more cans and removed the slag one more time before pouring the aluminum into our mold. While pouring the aluminum into our mold, molten aluminum started coming out of the parting plane. In order to prevent a metal fire, we placed sand around our mold as soon as we saw the aluminum coming out of our mold. After letting the part sit in the mold for a few minutes, we pulled it out and then placed it in water to help it cool faster. After cutting the excess aluminum off, this is what our final product looked like. For our first attempt, it turned out very well. With our final product being done, we asked ourselves, what is something we would do different next time around? Well, we would allocate more time to the product because casting is a time-consuming process. Furthermore, we would add a riser to our mold and pack our sand a little tighter because that would have helped prevent the aluminum from leaking out of the side of our mold. We did not have a riser this time around because it would have not fit in our sand mold. We had to ask ourselves, what are some things we did correctly and would not change? There are a few things. First is the foundry. It melted the aluminum cans very well and efficiently. The second being the sprue in our mold and the ventilation holes in our mold. The sprue went deeper into the mold than the part. This made it so we filled the negative space of the part bottom up, helping prevent splashing. The ventilation holes allowed for the gases to escape. The third being how we handled safety. We wore gloves when working with the ceramic fiber, used safety glasses when necessary, used casting heat resistance gloves when handling the foundry, and wore long sleeves, closed-toe shoes, and pants when appropriate. Furthermore, we preheated the crucible in an oven and in the foundry. This was done to prevent cracking of the crucible so we did not potentially cause a metal fire.